Alright, guys ready?
Yes.
Alright, so let me remind you what L'Hopital's rule says. It says so if you have a limit of the form zero over zero or infinity over infinity plus or minus, then you can take the limit by taking the derivative of top, derivative of bottom, and then plugging stuff in again and seeing if it works. Right, so that was from Friday. So today, the first example I want to talk about is so limit as x approaches infinity of x squared e to the negative x. Alright, so first thing you want to do whenever you have a limit is just to try to plug it in. Right, so if I try to plug this in, what's x squared? What's infinity squared?
Infinity.
Right, infinity. What's e to the negative infinity?
Infinity? I don't know.
So e to the negative infinity. So you remember, e looks like this. So if you go towards negative infinity, so if you go towards the left, if you follow the graph towards the left, what do you approach? So if you go this way, right? You go towards 0. So this limit is infinity times 0. So what's infinity times 0?
0.
Right, so we have, could be infinity, could be 0, or it could be 5, could be 10, could be 11. It depends, right? So this is also indeterminate. And what I want to do is I want to use L'Hopital's rule. The problem is L'Hopital's rule only works when you have either 0 over 0 or infinity over infinity. So the trick here is to rewrite that as a fraction. So I have to bring either e to the negative x or x squared down to the denominator. So what I'm going to do is I'm going to bring the e to the negative x down to the denominator. So x squared, when I bring it down, what happens to the exponent? Right, it becomes now e to the positive x. Right? Now try to plug it in again. So on top you have infinity, right? And then what do you have on the bottom? So on the bottom you have e to the x, so you plug it in, you have e to the infinity, which is e to the infinity.
Why?
So now you go this way.
Oh,
So if you go this way, your graph goes towards infinity.
so we need to memorize this.
Yeah, you should know the graph. Right, you see that on the bottom you have infinity also. So e to infinity means you go to the right on your graph, and if you follow your graph, you go up toward infinity. Right, so now it is in a form that you can do L'Hopital's rule. So now do L'Hopital's rule. So the derivative on top is 2x. Derivative on the bottom, e to the x. Okay, so do L'Hopital's rule. Try it again. Plug in infinity. So on top, what do you have? Okay, good. So on top you have infinity, on the bottom, infinity again. Do L'Hopital's rule again. Derivative on top, 2, good. Derivative on the bottom, e to the x. And now try it again. Plug in infinity again. So on top you don't have anything to plug in. On the bottom,
Isn't it just, infinity?
infinity.
So it's 0.
Right, good. So 2 divided by infinity is
0.
0. Any questions there? Alright. So let me give you, let's do another example. Alright, so this is a review of your logs. Alright, so try to plug it in. So you get a 0. What's the log of 0? Let me draw the graph here. So if you approach 0, where does the graph go? Yeah, so if I approach 0, right, this is 0, if I approach 0, the graph goes down, right? So it's actually negative infinity. Okay, 0 times negative infinity. Could be 0, could be negative infinity, could be 11. So this is indeterminate. And you want to use L'Hopital's rule. So you want to rewrite this as a fraction. And you have two choices. Either you bring the log down to the denominator, or you bring the x down to the denominator. Or bring the log. Okay. So you can bring the log, and what you get is that, right, on top. When you bring down the log, it will be now log x, negative 1. Or actually, let me rewrite it like this. So now try to plug in 0 again and see if you have a form where you can use L'Hopital's rule. So on top, you have 0. On the bottom, what do you have? You have 1 over, right, 1 over negative infinity, which is 0, right? Alright, so you do have a form where you can do L'Hopital's rule. So try. Now let me go back to this form, because it's going to be easier for me to take the derivative that way. So L'Hopital's rule, derivative on top. What's derivative of x? 1, good. So 1, what's the derivative of log x to the negative 1?
Negative one. Wait, yeah, negative one times log.
Log x to the
Negative two.
negative 2, and there's more, right?
Yeah, and I don't know that.
Right, so you did the power rule, right? Now what's the derivative of the inside? Derivative of log x. 1 over...
Oh, 1 over x.
1 over x, good. Okay, so let's try to simplify this a bit. So really what I have is so limit x goes to 0. So there's 1 over x here. I could probably bring it up top, right? Have x here, negative. Is everyone okay with what I did there? So, here's the problem. So, is this better or worse than what we started with here? Right, here I have x, and bottom I have log x to the negative 1. I did L'Hopital's rule, and I got x. Now on the bottom I have log x to the negative 2. Yeah, the power will keep on going. If you do it one more time, you get x over log negative 3, which is a problem, right? It's not getting any simpler. So, what do? So instead of bringing the log down to the denominator, maybe we should have brought the x down. Okay, so this is not going to work. Okay, so let's try this again. So redo. Alright, so instead of bringing the log x to the bottom, let's bring the x to the bottom. So I'm going to leave the log x on top, and now when I bring the x to the bottom, what does it become? 1 over x. Okay? So plug in 0. I get on the top, it's negative infinity, right? On the bottom, get 1 over 0, which is infinity of some sort. Okay, good. So this is in the form where I can do L'Hopital's rule. So let's do it. I'm going to rewrite the 1 over x as x to the negative 1, because that's going to help me when I take the derivative. So, L'Hopital's rule. What's the derivative of log x again?
1 over x.
1 over x. And the derivative of x to the negative 1.
Negative 1 x. So the negative 2.
Okay, good. And now simplify.
Isn't it just negative 1 over x? No. Wait, no, sorry. It's not right. Forget what I said.
So let me bring the x to negative 2 back up on top. stop is negative 1. It's 1 over x. When I bring it on top, it becomes x squared. And I still have this negative 1 here. So simplify, what do you get? So x squared over x divided by negative 1. So it's negative, right? X squared over x. Yeah. So x squared over x is an x. And now try again, plug in 0, and it works in this case, right? So you just get 0. Questions? Alright, so so this is 0 times infinity. There's one more type of indeterminate form.
In this case, should we always be x, or would we have to
So we saw that if we brought the lateral log down, it's not going to work. But if you remember in our first example, there's also an x, and we brought the e to the x down instead. Right, so this is just going to come from experience. So you bring one of them down, you try it, it doesn't work, go back, bring the other one down. That's kind of the only way to do it, yeah. Alright, so last example. So x to the power of 1 over 1 minus x. Try to plug it in. Let's see what we get. You get a 1 here, and what do you get in the exponent? You get a 1 over 0, which is a 1 to the, so 1 over 0 is infinity, right? So 1 to the infinity. Could be infinity, could be 1, right? There's 1 to anything is 1. So this is indeterminate. Okay, what do you do here? So I want to rewrite it eventually as a fraction. Problem is I have a x in the exponent, right? So usually, if there's an x in the exponent and I want to bring it down, what do I do? Yeah, you have it. Yeah, take the log. Okay, so what I'm going to do is, so this is the limit I'm trying to find. Let me call it L for limit. And now let me take log on both sides. So on the left, I have ln L. On the right, I have ln x 1 over 1 minus x. So the ln allows me to take this exponent down. So what I have now is Alright, is everyone okay so far? Okay, so let's just focus on the right side and try to find this limit. Plug it in. I get 1 over 0, right? Which is infinity. Log of 1. What's log of 1? Remember what log of 1 is? Yes. Log of 1. What do you calculate? It's an easy number. Yeah. So, log of 1 is 0. So, fact. That's a fact you should know. Log of 1 is 0. Okay, so infinity times 0. That's indeterminate. So what I need to do is I need to write this as a fraction. So it almost looks like a fraction right now, right? If I just write it as a fraction. Right now it's a fraction. If you plug in again, you see that you actually do have 0 over 0, which means you can do L'Hopital formula. L'Hopital rule. What's the derivative of log x? 1 over x. Derivative on the bottom. -1. So this simplifies to -1 over x, right? Plug it in. So -1 divided by 1 is -1. Right, but that's not quite your answer yet. Because remember, we took log of both sides, so on the left side of all this stuff is ln of L. And we want L at the end. So I really want L equals something. So solve for L, which means you do what? What? Okay, so to get rid of this ln, you can take e on both sides, right? So that will get rid of this ln, and on this side you have e to the -1, or 1 over e. Alright, any questions?